All right, everybody. Thanks for coming out on this beautiful evening. I know that it's way more fun looking out there with the ocean, but we're very excited to have Ben with us tonight. A couple of housekeeping items before we get started. This is brand new news. We're literally just now figuring this out within the last couple of days, but we are going to, in conjunction with the Boston AWS user group and the Hartford AWS user group, we're going to have an AWS Community Day. So down in Norwood, Mass, at the Sheridan Four Points, we're going to have an entire day of keynotes and breakout sessions and lunch, and we'll feed you guys breakfast and all kinds of good stuff. So as this progresses, as Steve and I work out the details with the other leaders, we'll get you more information in the Slack channel and via the meetup email spam option thing that we have.
Right.
Apologies if we've been sending out too many emails recently, but there's been a lot of cool stuff coming up. We were not able to call it pre-invent. That was put the kibosh. That would have been awesome, but that was frowned upon by the reInvent marketing people.
AWS did not want us.
They did not want us to call it pre-invent. So Community Day, not pre-invent, will happen on October 1st. Mark that off in your calendars.
Is it 8 sect or is it like still 2 weeks?
Sorry?
Is it 8 sect?
That's going to be the exact date.
Okay.
Yeah, so it is going to be October 1st. It's going to be at the Sheridan Four Points Norwood. I'll be sending out all the information as we proceed.
We'll send out the meeting invites.
Yeah, and once we get the speakers and everything. So that being said, speakers, if anybody wants to present for one of the tech track talks during the after lunch phase of that, please let me know. I've already had 2 people ask to talk. So we're going to see how many tracks we can get going. We're in a little bit of a competition with the Boston user group to see if we can get better speakers. I think we can do it. Additionally, the virtualization technology user group, the VTUG, is happening in Westbrook, Maine on July 19th. That's the other thing that I help with. That's going to be a full day of not just AWS stuff, but VMware, Microsoft, Google Compute. We're going to have a bunch of speakers up there, plus 20 breakout sessions, plus the evening at Gritty Mains, where you have a free lobster bake, all you can eat lobster, steak, chicken, beer. We have a hot air balloon. We have live band. We have high rolling cigars. It's ridiculous. 2,000 of your closest friends all having shenanigans late into the evening. Jonesy is going to be presenting there on vCloud on AWS, and it's going to be the best thing you've ever seen, right? No?
It'll be entertaining for sure.
So bring your tomatoes. Full disclosure, he's my boss, so use him as much as you want to. Okay, so with that being said, I'm super excited to see Ben. But Ben Kehoe is one of the AWS community heroes, one of 22 community heroes in the US. He's very smart. and take it away, Ben. Thank you.
All right. So hi, I'm Ben Kehoe. I work at iRobot, and I'm an AWS community hero. So I'm here to talk about serverless. iRobot is completely serverless, actually. We don't have any EC2 or Docker in production, supporting our connected robots and apps. And as we sell millions of robots a year, you can imagine we have lots of robots to our cloud. So who here is familiar with serverless, the concept? Most everybody. Okay. I don't have an in-depth set of slides around what is serverless, so I'll cover that a little bit now. The idea is fundamentally similar to the value proposition of Roomba, right? When Roomba came out in 2002, you couldn't replace an upright with it, right? It vacuumed and it got around your house okay, but it wasn't going to take, you weren't going to be able to get rid of the vacuum you had. But it did do good maintenance cleaning, right? And it gave you time back in your day to do the things that matter to you. And that's still true of Roomba, although we've gotten a lot better at navigation and at cleaning and all these things in the past 15 years. Serverless is the same way. Serverless is saying, you have better things to do than manage servers, than patch servers, than orchestrate fleets of servers or containers. You have business value that you're trying to deliver. And you should be able to focus on that instead of getting bogged down in technology problems that aren't part part of directly delivering the business value that you as a company. So that's what serverless is about, and the tools that we have to accomplish that are things like AWS Lambda, where you get to run code in response to events. Although, as I'll go into here, that's really just one little piece of serverless. And the broader important bit of serverless is about using managed services. Yeah, and as iRobot, we use 30 different AWS services in production. So we're advanced broad users of AWS services, but again, none of them are EC2. None of them are ECS or anything similar. All of our computation happens in Lambda or AWS Glue or AWS IoT, all of these managed services. And so serverless fundamentally is about more than just functions as a service, right? So a better term, like serverless is a terrible term, just like cloud was a terrible term that nobody liked, but we're stuck with it, right? And a better term is serviceful. This was Patrick Dubois who came up with the term DevOps, which is also now a term that means nothing. Because really what you're trying to do is you're trying to say, what can I not do myself? What can I find a managed service to do for me? Instead of running Kafka, can I use Kinesis? And instead of running my own Spark cluster, can I use AWS? Instead of hosting my own user accounts, can I use Cognito plus social login from Google and Facebook, and Twitter, and things like that? And for all the things that you can't find a managed service for, you want to bring in ephemeral compute for, which is predominantly functions as a service like AWS Lambda, but goes beyond that. AWS Glue is this managed ETL service, so it's essentially Spark as a service from AWS. And it's really great because Spark clusters are a nightmare to manage. It's a huge amount of work. Oh, something I didn't mention about our production thing, right? So we sell millions of Roombas, and so we have a large fleet of robots to support, and we support that with single-digit FTE operations personnel. So the system basically runs itself. We really don't have to do anything to keep it running. And this is what things like ephemeral compute bring in, is when it's ephemeral, all the things that you have to do to keep computers running, someone else can do if you only need to use it for little bits of a time, and then it can disappear because they can make other stuff happen while it's happening. And then another facet of serverless that's important is that your resources that you get billed for approach more and more closely the resources that you're using. Right? This is the thing about Lambda. You don't pay for idle. Now with Lambda, of course, if you make a long-running HTTP call inside your Lambda, you're not using any of the resources that the Lambda has blocked out, but you're paying for it. So you're paying for waiting, even though you're not paying for outside of the function location. Whereas on something like a Node.js server, you can mitigate the overhead of those waits. Lambda doesn't do that yet. You also want a smaller and more abstract control plane. And that's about having to turn fewer knobs to get the kind of scale and performance that you need. And it's not that the knobs may not be available, but it's important that you not have to touch them at first, right? That the amount of configuration that you're doing to get the initial part of scaling is out of the box, right? And then, as an advanced user, you start to want, oh, let me tweak it and get a little better performance out of it. That's part of it, but you want less to do. But more important than the what is the why, right? And so a lot of people think of serverless as a lower cost, right? You don't pay for idle, and it can reduce your cost a lot. There are all these success stories of, oh, we're paying $30,000 a month, and now we pay like $500. And that's cool, right? And that's good. But more important than that is that you get a lower operations burden, right? So you have less to do to make it do the thing that you want. And along with that comes a faster time to market. There's less stuff that you have to do to make it happen, and therefore you can get it out sooner. Which means that you can focus on your business value, which ultimately is the important part of serverless, right? That's what it's all about, is being able to do the thing that you as an organization are supposed to be doing and not doing stuff that doesn't matter to it. So the idea is that serverless is like masonry, and the functions as a service are just the mortar. They're just how you stick the bricks together. The bricks are what bear the load. You want to buy those. You don't want to get into the business of brick making or clay mining. None of that matters. Just buy them, and maybe they're not all the same color. It's fine. They'll still hold the weight. And so Ed Anderson said this a while ago, that serverless is a hammer. Make sure your problems are nails, which is true of any tool. I thought about, like, when I was making the presentation, I was thinking about, like, torturing this metaphor for all it's worth, and like screws, bolts, and development of the power drill, and like all these things. And I decided not to torture anybody with that. But the point is that this hammer, right, is extraordinarily powerful. And we see that at places like iRobot, where we've been able to do this with a development team of 10 people, 15 people, and an operations team of just a handful. And we can run a large scale cloud application with nobody and churn out features really quickly. And what we've found, being entirely serverless, is that there's a big difference between all serverless and mostly serverless. And this is true especially for operations and less so for development. For us, adding one EC2 instance into our production application would entail a large jump in the amount of operations we have to do. And so we try as hard as we can to stay away from that. Eventually we're going to have to put it somewhere, have something that we can't quite get out of managed services on AWS. But we're highly incentivized because of this to stay all serverless. And that's an important thing to know, is that sure, you get a lot of the benefit as you start to bring serverless into like a hybrid system. But if you can actually go the entire way to entirely serverless, you get a step change in the benefit, which is what happens when you go all in. And so I'm here to tell you that it's not easy, but it's worth it, which is what the rest of this talk is about. So this mindset for being serverless native. And there's sort of three things here. There's this cheesy phrase called profoundly found elsewhere that we'll talk about. I want to convince you that attachment is suffering, at least for cloud compute, and that you have to be okay with Rube Goldberg machines. So the first bit here is that whenever you're faced with a technology problem, you have the build versus buy dilemma, right? And in a lot of organizations, there's a behavior that you can identify that gets referred to as not invented here, where people don't trust things that have been developed outside; they want to own it. This is common. This crops up everywhere. That people feel more comfortable when they control something, which is that's human. It's also true when you look at like buy versus host, right? Is hosting your own software, you have more control over it than someone else hosting it for you, right? So it's the same philosophy. And Procter & Gamble had this sort of systemic problem with not invented here. So they embarked upon this program to root it out, and they developed this phrase, profoundly found elsewhere. I was like, oh, it's the reverse of not invented here. Whatever. I found this art installation that says, be afraid of the enormity of the possible. And for me, I think that's a good phrase to remember, that whenever you're looking at a problem and you're faced with this build versus buy, and you think, oh, I can solve that. I can make something that will do that. The complexity of the problem that you're looking at and the amount of work that you think you're taking on is usually much bigger than what you're estimating at the start. There's that, is it Hofstadter's law, that it always takes longer than you expect, even when you take into account Hofstadter's law. And that's what this is saying, right? Is that, okay, you say, oh, I can do that. And the answer is, it's much bigger. All the possible things that are in there, you should be afraid of. and make that trade-off. And these restrictions are actually good. And in this way, serverless is like minimalism, right? Don't own what you don't have to. The implication here is that you should use managed services in preference to buying or hosting your own software, or building or hosting your own software, as much as you can, even if the services aren't perfect. And I'll go into that in a little bit. A common not invented here that we find is related to multi-cloud, right? You hear this get talked about a lot, and there's sort of two ways that people think about multi-cloud. One is to be afraid of vendor lock-in. That comes up all the time in serverless discussions. And the other is a desire to use the best services possible regardless of the provider that they come from. And the first problem is much more insidious. But it's not a real threat, right? That when you hear people talk about, oh, I'm worried about vendor lock-in, you know, what people do then is they build an abstraction over the cloud provider that they're on. And they say, I want an abstraction that will allow me to switch out the provider underneath. And that means that their abstraction has to be the lowest common denominator between all of the providers. And that means that they don't get to take advantage of any of the unique features of their provider that makes that provider's offering powerful in its own way. Now, if you're running containers, if you're running VMs, that abstraction is relatively low, right? Like especially if you're running on, say, Kubernetes. It's pretty easy to pick up and find a managed Kubernetes between Amazon, Google, and Microsoft now. But when you're serverless and you're using these managed services, you end up with, you know, a lot more particular APIs. And so this abstraction starts to hamper you more and more, the more serverless you become. And there's sort of an easy way to demonstrate that multi-cloud is not a real threat. And it's related to cow tipping. So cow tipping, right, is the purported activity where people go out and they push cows over and the cows fall over. And, you know, sort of an urban legend, and for a long time, people debated whether or not it was possible or not. You can prove that it's not possible by going on YouTube and searching for cow tipping. And there are no videos of people successfully tipping over cows. If it was possible, there would be videos of it. And if you look at people talking about multi-cloud, there's no companies out there saying, we went multi-cloud and it really saved us, or we didn't go multi-cloud and it really came back to bite us. There's nobody out there saying it. There's everybody who's talking about it as a risk and how they're mitigating that risk. And they don't talk about sort of the total cost of ownership. They don't talk about their opportunity cost there. How much time are they spending on this that they could be spending on, you know, features for their business, and what they're missing out in terms of performance or capabilities in their application because of that, right? Even a company like Spotify, right? Spotify picked up from Amazon, moved to Google. They're not saying, oh, now we've learned our lesson, we're abstracting over Google so that we can move in the future if we have to. They're all in on Google. And in a situation like that, you're gonna get, you know, a huge break from the new provider to help you move. And Spotify is now saying, it's worth it for us to be all in on Google and pay that price again if we have to move later. A company like Netflix that is multi-cloud and does that, their problems are not any of our problems, right? They're at a scale that makes it worth it to expend the energy to arbitrage between providers. But until you're as big as Netflix, it's not worth it. However, so multi-cloud is not a real threat. But what is real is that people are afraid of it. And when people are afraid of something, a security blanket is a useful thing. And the Cloud Native Computing Foundation has this spec that they're working on called Cloud Events. And this is a cross-provider standard for event interchanges. And I'm really excited about this project, which may sound contradictory from what I said. But the thing is, right, so this is a spec that says, all right, I'm in Amazon, and if I ever want to ship my events over to Microsoft, there's a format that's gonna let me do that. It's gonna let me plug Amazon into Microsoft, and Microsoft into Google, and all these different things. And the way that I see that is, people will see that and say, oh, now I don't need to worry about vendor lock-in because I can ship my events in my serverless system elsewhere. And then no one will use it because it's never worth it. But it means that they won't spend time or energy trying to be multi-cloud and trying to solve that problem and wasting the time on it. So I think it's a useful thing to solve the real problem of people worrying about multi-cloud. So the other piece is this, this desire to use the best services possible. So I want to use, AWS Lambda and DynamoDB, but then I want my analytics to run in Google BigQuery because I like that better, and then I want to ship, over to, I don't know, I'm the least familiar with Azure, and so something on Azure that also, so I want to pick and choose my services from the providers. And data gravity is a real known thing that is already going to get in the way of that, right? If all of your application data is in Amazon, shipping that all over to Google and back to do analytics on it is going to be expensive. For the incremental gain of whatever better service, analytics service that they might have, that's how it works out for you. Similarly, in serverless, there's now integration gravity, right? The ability to plug services together is going to be much easier within a provider than it is across providers, even with something like Cloud Events in the mix. And so what it just means is that you have to be pragmatic and focus on your total cost of ownership. We're, for all of our primary services, we're in Amazon. We use a few third-party services around mobile analytics and user accounts and all these various things. But for any of the sort of core standard application components like databases, like messaging, like computation, it's all Amazon. And if we were to try and open that up to another cloud provider like Google or Azure, our operations burden would go up because now we're trying to monitor multiple clouds, which have different ways of working. And so it could be worth it. It could be from either a monetary or a speed perspective. But you have to look at the broad picture and what does it mean overall, right? Not picking individual metrics to compare on, but looking at the big picture. So I want to pause there and make a short rant about what serverless is. So there's these new services like AWS Fargate, which is a managed container execution environment. So basically, if you're familiar with ECS, it allows you to have the EC2 instances that run under ECS. Instead of you having that fleet yourself, Fargate manages that fleet for you. And it'll eventually plug into Amazon's managed Kubernetes service. There's also these hosted functions as a service platform. There's OpenFast, there's Kubeless for Kubernetes, there's OpenWhisk, which is, there's a managed version of it on IBM's cloud, but it's also open source and you can run it on your own hardware if you want. And sometimes they get referred to as serverless. OpenFast is like, oh, it's serverless functions. And there's this important difference about what's being managed there, right? That you can manage your infrastructure, or you can manage compute. And unless you're doing both, you're not really fully serverless. So if I look at AWS Fargate, that's managing my infrastructure. And that lets me run containers without having actual EC2 instances that I have to manage. the same time, I get a container. On top of that, I can put a Node.js server in there, and that is a server. It is active when it's not handling data. Paying for it. It's a server, right? Or I can take a functions as a service product, which is managed compute, and run it on a Kubernetes cluster that I'm running. In that case, sure, I've got managed compute, but I'm managing infrastructure. So I'm still doing more work than I should when I'm trying to be serverless. So now I want to sort of convince you that attachment is suffering for computation. And so when we moved to the cloud, we talked a lot about, servers used to be pets. They had names, we cared for them, they lived for a long time. And we were supposed to treat them like cattle. So they have IDs, if they get sick, you replace them, you don't get attached to them, and you have lots of them, right? And they're all identical, you don't really care. And I like to joke that when you have serverless, you treat servers like roaches, and you stamp them out wherever you can. I think that's oversimplifying it. And what they should really be is mayflies. So mayflies are these bugs, right? They are born, they live for 24 hours, find mates in those 24 hours, and then they die. And somehow it works out. But the important thing is that the cycle is really fast. And when you look at how you want compute to work in a serverless environment, you want it to be ephemeral. And you want it so that if you're not handling any data, you don't have any compute running. And this is, again, more than just functions as a service, right? So functions, if you have an event coming through, you run a bit of code in response to it, and then when that event is processed, the compute goes away. But if you look at like batch jobs, right? Batch jobs aren't event-based. They're run, but they run through a finite amount of data, and then they're finished, and then they go away. That's also an ephemeral compute. And there are solutions like AWS Batch or AWS Glue that allow you to have ephemeral compute around batch processing. So the important thing is that for any given computational resource is that its lifetime is tied to something that's finite. So the next aspect of the serverless mindset is when you take all of these pieces, right? So iRobot runs 38 AWS services. It means that you have to be comfortable with Rube Goldberg machines. That you've got so many of these different pieces running around that there's no easy way to sort of centralize or bring the complexity into significantly smaller units. And one of the reasons for this is that what happens when you move from server-based computation into serverless is that many of the things that you were doing in your call graph inside your code turns into your component graph in your infrastructure, because you're using managed services to do things that you had code doing before, and that code can get put in the same place so that it's just a function call, and you can trace through that execution. But now there's a network call in between, and so this code is separated from this service. It's not even your code anymore, and there's just an SDK that you see in your code. And it means that you then have these much more complicated infrastructure graphs. And it's possible, right, that at this point you become, this is where multi-provider could come in, that Amazon doesn't sell parrots, so you have to go get that from Azure. And so what you ideally want from your provider is Legos, right? You get little building blocks, they fit together, and you can make whatever you want from it. However, it's not always what you get. Sometimes in that bucket, you find bricks that don't fit together with the other ones, even though they come from the same provider. So, a few examples of this. right? SQS and Lambda still don't play together. You can't invoke a Lambda out of an SQS queue. It's supposedly coming. It's been announced, but you know, we've been waiting 3 years for this. And then also there's things like, so API Gateway and Lambda both have weighted traffic direction between versions. It's weighted aliases in Lambda. It's canary stages in API Gateway. And they're very similar concepts. They're the same concept. And the amount of traffic that you turn in a weighted alias goes between 0 and 1. It goes between 0 and 100 in API Gateway. There's no good reason for that, but it means that in like cloud formation, you can't control them with one parameter. And so when you run into something like this, you often are like, well, how do I stick this together? Do I have to introduce more computation or something else, or do I give up on this? And the answer is duct tape. That when you're serverless native, you find ways to make it work. And so for SQS, the way that this has worked is that you set up a timed event, a timed CloudWatch event, to invoke a Lambda that will go and read from your SQS queue for 5 minutes, the length that a Lambda can run for, and then you set that event to go off every 5 minutes so that you essentially have a continuously running Lambda polling that SQS queue. And then it's forking off workers to go work on those events. And similarly, RDS, the managed database service, the managed relational database service, doesn't have an HTTP query interface, which makes it hard to use with Lambda, because database connections are meant to be small and shared, like small in number and shared. And with Lambda, you have many, many of them. And so you can choke the number of connections. And the other bit is that the container gets frozen in between Lambda invocations, which means your connection can break, and you may incur the cost of setting up a database connection more often than you would like. And our answer to this has been, we just use DynamoDB, even for things where it would make more sense to use a relational database than NoSQL. DynamoDB, we can figure it out, we can do the joins that we need to do on the client side, and it works well enough. And when RDS gets an HTTP interface, we'll start using it. But
Sorry, why do you need an HTTP interface?
So a database connection, like a JDBC connection, is intended to be long-lived and shared by lots of different requests. And Lambda says you get one container per concurrent execution. So if I have, 100 requests running at the same time, that's 100 different database connections that I need to have. Even if the calls to the database are not concurrent, right? If your function runs for 1 second and 1/10 of that is the call to the database, that connection needs to be open for that whole second because it's long-lived, right? And if you're running on a server, they could all share the same database connection because you could interleave them. But you can't do that in Lambda. And then with Lambda, right, if I invoke it and it's the first time that container gets started, I open that connection. And then it lives through that execution. And at the end of the execution, the container gets frozen, which means that there's no keep alives going through that database connection. Now, if I invoke that function again and that container comes back up quickly, it just looks to the database like a network interruption, and maybe that connection stays alive. But maybe it doesn't, and now I need logic in my Lambda to say, oh, even though this container isn't new, I need to actually reconnect to the database. And I'm incurring that even though I'm not cold starting the Lambda. So now I have additional latency for that function call. And that's not, so, and if it was HTTP, I wouldn't be incurring that.
So they actually launched, I don't know if you've heard of, it's AppSync, which
Yep.
is GraphQL,
Yep.
which is similar to REST, which you don't have to.
So AppSync, AppSync is a great service around that is very useful when you have a client that all of your logic resides in. And the thing that AppSync is doing is relatively simple, right? If it's just fronting databases for you, then that can be very useful. But if you need business logic between AppSync and your database, if you need a custom resolver, you run into the same problem. You have to have a Lambda there, and then you have a connection problem again. And but in general, AppSync is great. You can also connect it to DynamoDB. You can have these custom resolvers, right, to connect to whatever data storage you want, and that's all useful. And like Athena has an HTTP query interface. It launched with just JDBC, but now it has an HTTP query interface. It's much easier to use with Lambda. So I'm hopeful that Aurora will get that eventually. And AppSync is actually a good example here, is that one way that you can reduce the amount of duct tape that you have to build in the cloud is to move logic into your client. So the more, right, that if all you need in the cloud is providing access to data storage or similar sorts of low-level primitives that your client can use to build your application, that the integrations that are built around the services are generally much better there. And that allows you to do whatever you want from the client. So you can put your business logic there. Another thing that's been really important for us, so we're heavy users of CloudFormation, and CloudFormation custom resources are super useful. So this is a way to control cloud resources that CloudFormation doesn't support natively. And so that's been useful to us if, AWS IoT is a critical part of our application, and it wasn't supported at launch. So we had custom resources that supported it. Anything, it doesn't even have to be AWS services. I once said that CloudFormation could control anything with custom resources, and a friend of mine challenged me to turn on connected lights. It took me half an hour, most of which was figuring out the API to the connected lights. We have a library up on GitHub that we found has been very useful in making that simple, because we found, once we said we want to be all in on CloudFormation, we found we have to make it as simple as possible for people to control new things with CloudFormation. It's in Python, but there are other Python libraries out there, the JavaScript ones. Find one that you like and use it, and then you can use CloudFormation to do more powerful things. So you may be skeptical at this point, because I've talked about all of these rough edges that Serverless has. And it's true that Serverless is not simple to be all in today for complex applications. If you have an application where you've got a single page app where the bulk of your logic resides, and all you need is storage from the cloud, right? And some flows you can trigger off of storage, then Serverless is going to be easy for you, right? You can use AppSync, you can use API Gateway, Lambda, and DynamoDB. There are lots of sort of relatively straightforward solutions you can go for. For us, where we have a large-scale IoT application with both mobile apps and robots, it means that, again, we have 30 different services that we have to use to provide this. And it hasn't been easy, and there's often times when you're sort of racking your brain trying to figure out how you're going to solve it in a reasonable way. But it is worth it. And again, going back here, the what doesn't matter. It's the why that matters. And of the reasons, the one that's important is focusing on business value, right? That what this has enabled as a company, as we moved from a non-connected robotics company to being a connected robot company, is to not have to be a cloud technology company. We don't have expertise in scaling fleets of servers. We've never had that. We were able to go, and we sort of lucked out in this, in that we were able to build this as serverless technology matured, but it means that we never had to develop that capability, and so we never had to spend resources doing that. And that has enabled us to put those resources towards improving the product, towards developing features, towards innovating on new robots. And so as you push that, right, again, you sort of get diminishing returns as you approach the entirely serverless point, until you actually get rid of all of your servers, and then you get this big gain. And it's important to figure out, sort of where that balance is for you. And if I've convinced you, then the question is sort of how do you get to this point? How do you adopt the serverless native mindset? And right, again, it's all about control. You have to let it go. And to embrace serverless, right, ephemeral compute is extremely useful. And event-driven architectures are useful in this context, because events by their very nature are ephemeral. If there are no events in your system, why would there need to be any computation running? You have to make a cultural shift, right, to avoid not invented here syndrome. You have to get people in the mindset of, I don't want to own this. You have to have people thinking about what is the business value of the problem that they are solving, and keep them focused on that so that they don't get diverted into thinking about just a technology problem, but rather how it serves the business needs, which is, again, all a question of focus. So it's worth the trouble, and it's only getting easier, right? When we started working with serverless in 2015, it was really hard. And now it's a lot easier from the services that are available, the tooling that's available, the community that's out there, and it's only getting better as time goes on. So that's all I've got, and I'm happy to take any questions. Yeah?
I got one. So when you talk about this whole serverless thing that just responds to events, so I'm imagining like an app that you build that somebody can check to see if their vacuum is still under warranty, for example.
Sure.
Where do those events come from? Like, isn't there some server somewhere that's hosting the
There's always a
person
server.
logging in?
Well, so there's
That's
always
the part
a
that
server.
I'm missing, I guess. Yeah.
So,
So that's someone else's server?
yes. So with Lambda, right, AWS is managing a fleet of servers
Right.
that I don't have to patch, that I don't have to see, that I can't log into,
Right.
which
There's
is
still a front
important.
end somewhere that you have to put code on and,
So with Lambda, right, what I'm doing is I'm zipping up some Python code
yeah.
that I give to AWS and say run in response to these events. I connect it up. And they provide the runtime, the Python runtime. So they're updating the minor versions of Python, so I don't have to do that. And
Isn't that just the response to the query though? Like, the query of, is my vacuum under warranty?
yes,
It looks
so
up
that
the
comes
data.
in, that's an HTTP request, right?
Yeah. Where does that come from?
That comes from, say, an app, right?
Which is not serverless, right? It's
Well,
on a
yes,
server somewhere.
Which server? Like the app, like
The front end.
well, there's
Like I build
mobile
an
apps.
Angular and we have APIs that are
Yep.
like in Python.
Okay, so
or PHP,
yes.
And then we have a front end that's on IAS or something. You can't get rid of the front end.
Well, okay, so there's two things
Okay.
here. So if you have mobile clients,
Yeah.
those aren't running on servers, which is
Good
what we
point.
have,
Okay.
right? So
Yeah.
our consumer applications are all mobile apps.
Okay.
For our internal stuff, so we have a fleet management console that you can go in and you can say how many robots are connected, right? And you can, customer service can go in and say, show me this user's mission history.
Yeah.
And the way we do that to stay serverless, so you can use something like API Gateway backed by Lambda to be your web server. So when a request comes in, there's an HTTP request and it says, I want this page, and you have a Lambda that's rendering your page, and then
Okay.
serving it back out through API Gateway. And there's actually, there are libraries and tools out there that help turn like Node.js Express apps into, put those into Lambdas. so that you don't have to have a server running to serve it. You can just sort of convert it to running in a Lambda, which essentially means the way that works is that when that Lambda starts up, it starts up a node server in there and serves out the request, but you just get many copies of that. But if there's no traffic through it, none of them are running, you're not paying for it.
Okay.
However, if you've got something like Angular, so what we do is we say single page apps,
Yeah.
all static content. So we serve it out of S3. S3 is our web server. And that includes, so the logins, right? They go hit an API, but all that logic is in the page to go do that. So it accepts your, username and password and goes and hits an API to log in and get credentials. And it uses those credentials to access an API. And so all of that logic lives in the client. And that's that thing about you can reduce a lot of cloud-side complexity by introducing it in your client. Because often you have a lot of front-end developers anyway, which in general, those people are the people that are delivering the direct value, which is your user experience.
Right.
And so adding on to that, you need to have this capability of determining what you need out of the cloud. They're often, very close to the business value and the business needs. They're in a good position to say, these are the APIs I need, this is what I'm looking for.
So you actually have a Lambda that would return back the equivalent of an entire rendered page?
No, so we don't have that. We have the static content.
Yeah.
So there's a static,
As simple as possible.
well, there's an HTML page that loads a bunch of JavaScript,
Yeah.
right? That's Angular, that renders the page on the client side. And so we don't actually need any HTML, like none of our Lambdas have anything to do with HTML. Because all of that is statically served and client-side rendered.
I think I got it.
Yeah.
All right. So you make a bunch of vacuum cleaners.
Yes.
How many Lambda instances or functions do you have to support? I mean,
Yeah.
you know what I'm getting at. Like,
Yeah.
all I know about iRobot is you make these awesome
Yes.
vacuum.
So we make the Roomba, right? So serverless lends itself well to a microservice architecture.
Sure.
And we like Lambdas that are single purpose. And so we have, a couple of Lambdas per service. If it's a CRUD service, there's a create, read, update, and delete Lambda. Maybe a couple others that handle, lifecycle events in that service. And so across the system, 100-ish. But the other thing is that then one of the consequences of that is the number of Lambda deploys that we do per day across all of our accounts. So not in production, but across all of our accounts is in the thousands. And so you end up with a lot of infrastructure churn in your accounts, which is something that you want to watch, right? And monitor
Sure, yeah.
for security reasons and all those kind of things.
But
Yep.
yeah, that's a great answer. What I'm a Roomba that
Yep.
that in your living room, and what am I asking for or sending to
So
through the API gateway to a Lambda function?
So there's a couple of things. One is that the Roombas primarily connect to AWS IoT, and this is a whole separate thing that we do. When we have events with AWS, it's sort of toss up whether we get put into the serverless track or the IoT track. And so AWS IoT is this connectivity layer, and the important thing about it is, if you're familiar with AWS's authentication mechanism, they call it Sigma4. You have this like key pair that you use to sign requests. AWS IoT doesn't do that because, that's hard for robots, for embedded devices to have that complicated logic in there. Something that is in every embedded device and should be used by every embedded device, especially, is SSL, right, or TLS. And the way that works is that, right, you have a private key and a public key and a certificate that's associated with it, and you open a secure connection between the device and server in the cloud. You can use that certificate to authenticate that connection. And that's often used, that's used all the time for authenticating the server, right? This is, where the little icon pops up in web pages around, oh, there's some root CA that you trust, and so you know that server is who it says it is. What's not often used on the web is the server can authenticate the client. And with AWS IoT, that's how that works, is that so the details of it are that iRobot has a certificate authority that we give to AWS IoT, and we prove that we own that. And we say that any device that comes in who has a certificate signed by this certificate authority, you should trust and let in. So then when a robot connects, it has a certificate that it signs that TLS connection with, and includes its certificate authority signature. That gets opened up with AWS IoT, and you get this mutually authenticated connection. Over that is a protocol called MQTT, which is an IoT protocol, and then that enters into the AWS IoT pub subsystem. So there's a topic space, and you can do this, and there's this some storage in there for asynchronous communication. And so that's a big part of our architecture, is that connectivity layer that's AWS IoT. The app also connects. It has AWS credentials through Cognito and connects over WebSockets. So because the app can use the mobile SDK and all that, we don't need to connect with an MQTT client. We can just connect with WebSockets and actual SIG4 signing.
Okay.
So we avoid having any SIG4 code on our robots. At the same time, they do use HTTP connections connecting to API Gateway to do service discovery. So if we want to, as we roll out updates and things, the robots need to know what endpoints to hit. So there's a well-known domain and URL that they go to say, hey, give me my endpoints. And that's an API gateway with CloudFront in front of it, right? All of those things.
Is that the AWS API gateway? Or
Yes.
Yeah.
Yep. And then behind that is a Lambda
Okay.
that goes into the DynamoDB
Yeah,
table.
I'm trying to
where
piece
the
together the
details are
architecture,
about all those things.
the chain of calls, and how the transaction works its way through to
Yep.
to the Lambda from the device.
So then also an example is at the end of a mission, right?
Yeah.
The robot sends up an MQTT message, the mission report about what it did, and that goes up into AWS IoT. That goes from IoT into a Kinesis stream to a Lambda, and then a Lambda into DynamoDB table. Now, off that DynamoDB table is a Lambda that's listening to updates on that table and sends down a request to the robot for the map that it builds as part of the mission.
Oh, okay.
It includes a pre-signed URL for S3. So the robot receives that, and it gets this URL, and it says, okay, I can send that up to S3. And so that's how we upload the map, which is a binary that's bigger than we want to send through MQTT. And then,
So over time, the Rumba is actually developing a map for the space it's working within.
yep,
And
that's
it's
part of our
storing it.
visual navigation. We build
Gotcha,
our
okay.
own.
Yeah, and you've got mobile, your mobile device is how
Exactly. So that's the other
owners
thing,
interact
is
with the
that
device. I see.
events that are part of that flow also trigger SMS to send a mobile push notification to the app that the mission is finished and that there's a map.
So compilation of the map happens with the Roomba or in the cloud?
So the Roomba, well, the 900 series Roomba has a camera on it to do visual navigation, right? And it builds the map internally, both because you wouldn't want those images unnecessarily leaving the robot, right? We don't want them in the cloud unless we have a very clear customer value that we can provide by having those images in the cloud. And so, there's a lot of complexity in visual navigation on robots. At the end of the mission, it can produce basically a simplified version of the map that it can send up to the cloud, and then we can show it to the user so you can see where it went.
So the purpose of the map is just to show where the robot is in the middle lab.
So the purpose of mapping is to build an understanding of the space for the robot.
So it works more efficiently the
Correct.
second time, right?
So
Third time,
currently, the 900 series robots don't keep the maps between missions. And the reason for that is twofold. One is that both, between the images and the maps, we don't need to keep it for security reasons. But more fundamentally, the ability to re-recognize the map in different lighting conditions is very difficult. It's something that we're working hard on and that we've made a lot of progress on. But without a very good ability to recognize, your house looks extraordinarily different in the day versus the night with lights on, and even just between different times of day. Because if you think, have you ever seen that there's this optical illusion with it's like a white and gray checkerboard, and there's a green cylinder on it. It's casting a shadow, and because of the shadow, there are two squares on the checkerboard which look white and gray, but they're the same color. And we look at it and we perceive it as a scene that would be likely to happen in the real world, and so we see them as different colors. The robot would see them as the same color. And so similarly, when it looks at a wall with a shadow on it, it does not see a wall of one continuous color, it sees two very different colors. And it comes back a different time of day where those colors are radically changed, and it's unlikely to see that as the same wall. So these are robotics problems.
Yeah. So the map is the map isn't used more than one
Right, but it allows it, right. In our next generation of robots, that's a problem that we solved. Yeah, so it allows it to make sure that it's clean everywhere, right? And then the persistent maps, right, the maps that last beyond runs, allow us to build an understanding of the space over time, which then, once we can reuse maps, then we understand how the space changes, and how your usage of it changes, and how that fits into your smart home usage, so we can start to provide experiences around that will enhance those things.
You guys gonna get into security devices? Robots chase burglars out of the house, take photos of them with Alexa's voice,
Well, you get the dogs that ride them, so you really need your guard dog trained with the Roomba. Yeah.
So you brought one example of what I call a long workflow, not necessarily long running, or chain workflow. It was the robot sending data to the IoT gateway, from there into Kinesis, from there into Lambda function, into DynamoDB, up into another Lambda, and out.
Yep.
How do you test those long chain?
Well, so there's a couple of things. The amount of code that belongs to us that's in that flow is pretty small. And so we do two things. We do extensive unit testing. So when you're using 38 AWS services, there's not really such a thing as local locking of services, right? You're never going to get, if you're using API Gateway, Lambda, and DynamoDB, you can get away with the local versions that people produce. But they're never going to be up to date with all the services that you may be using. So we take the approach that the code that we put in Lambdas gets extensively unit tested. We use a mocking library called Placebo that allows you to, it's a Python library that allows you to record SDK calls. So you make an SDK call to say DynamoDB and retrieve some data that you've mocked out in there. And then that records a file for you. And then during testing, you put in playback mode, and it goes into the SDK and says, don't actually call out to the internet. Just return this thing from this file that I've got.
What's the library called?
Placebo?
From the iRobot?
No, it's from Mitch Garnett, who is the original author of Bodo, the Python SDK for AWS. And there's a similar one for JavaScript that you can find. And so the important thing is that then you can run your code that makes AWS SDK calls locally, and it will not talk to the internet. So you don't actually have to have credentials for it, for that testing. You don't have to have data that's running in the services. You can just do pure unit testing there. So we found that very useful. And so we do that extensively, and then we do integration tests on deployed system only. And because part of that thing is, how do you test that your connection between AWS IoT and Kinesis is going to work the way you think? You can only do it if you put it up there. And so, and then from a developer flow, some of our developers like to do, they stick with the unit test for a long time, and they just do a few integration tests towards the end. And there's some developers who, they write their unit tests and they get it mostly working, and then they put it in, they deploy it, and then they work on the deployed system and make sure that's all working, and then go back and sort of pull those pieces down, integrate them back, finish the unit tests. So it depends on preference.
Okay.
Yep.
Yeah, so we've been doing serverless for a while. I think our biggest problem is logging, just because we're using X-Ray, but it's still a bit of a mind trick navigating things when they go wrong. I was wondering if you have any insights into
So
logging.
the problem with X-Ray is that so AWS is very good at building independent teams that don't need to talk to each other. And a consequence of that is that they don't talk to each other. They don't coordinate. And so a team like X-Ray has the extremely hard job of going to all of those teams and trying to get them to work together to accomplish something. CloudFormation also has this problem, but they've been around a lot longer. And so the problem with X-Ray is, like, if you look at that workflow, right? We've got a Lambda that calls DynamoDB, and then a Lambda that gets invoked on the DynamoDB stream that's coming off of that. X-Ray can't trace across that whole thing. And until I can do that, it can't tell me enough information. So we log the Cloud Launch a bunch, both in our Lambdas and then from the services themselves, and we pipe that to Sumo Logic. That allows us to do testing. But again, and that's for our deployed systems. For development, again, we focus on a lot of unit testing for the code that we're writing. And then for the integrations, that tends to be end-to-end testing. And the debugging of that can be hard, but yeah, it's one of the rough edges. Yeah.
I've never heard that Lambda fails, but my guess is that all your operations, as you said, are based on Lambda. What happens when Lambda fails?
Oh yeah, Lambda's been down a number of times. And so this is, again, one of those control things, right? Is when there's an outage, there's a couple of things. One is that you own that outage to your customers, right? That sure, you're not the cause of the outage, but to your customers, you still need to say, this is our outage and we're owning up to it. And then in the wake of an outage, making sure that you're focusing on total cost of ownership, because the impulse when you have an outage that you have no control over is, like, it's really painful. And you say, oh, if only, we own this, we could be fixing it right now. But the truth is, most likely, if you ran it, you would be worse at running it, and you would have more outages than they would. And that's not always true, right? And the other thing about serverless is, right, handing off control of systems is not always in your business interest. So if you need extremely low latency in your, in the requests that come in, you're not going to get that out of serverless, because the nature of, handing off the management of this and getting those higher levels of management that allow you to, it's easier, but you have more latency when you're using API gateway and Lambda than you are when you're just making direct calls through a reverse proxy or a load balancer to a bunch of servers. And if that's critical to your business, like if latency impacts your customer's happiness in a substantial way, then serverless might not be the right thing, right? And so similarly, some of those outages things, if it's absolutely critical for your business, either the answer is, well, you should own that technology so that you know exactly, you can make sure that you know about those outages, but then that's taking on a lot of technological investment. The other thing is about, sort of like interregional failover, you protect against it. So we at iRobot, it's the sort of thing where with the Roomba, if major AWS services are out, there's often a big impact on a lot of the internet. And when you're at home on the same network as your robot, the app and the robot connect directly. And you don't need the cloud to be there for it to work. But you can't get, like the history of your cleaning missions, that kind of a thing. And so we've got, sort of mitigations against outages. So we don't need regional failover at this point. At some point, the services that we provide through our robots may be critical enough to our customers that we need better uptime than is provided by being in a single region. And then we go to a multi-region solution. So,
multi-vendor.
yeah. What's that?
Multi-vendor.
Well, so a multi-vendor solution, so if you look at like AWS has never had a global outage that's affected more than one region at a time. Google has. All of their networking went out once because they had a DNS problem. But in general, once you're multi-region with a single provider, you're unlikely to have, impacts across both those regions.
Yeah, it must be more common, I'm not speaking from experience, but it must be more common to build resilience into your apps like you said you have, right? So.
So the other thing is, right, the outage happens. And one of the things about using many services, right, is that each service has some frequency of outages. And it's additive, right? This service is acting out. And the cloud has weather, right? Because it's not always, this is down. There's increased latency, or there's a few 500s, 500 responses coming back. We've been looking at a place where we're doing some DynamoDB replication. We're losing like 0.1% of calls get like a series of errors back from the put item call, and so we're losing a little bit of data there. And we're trying to figure out, like, do we care? Is it important for us to keep that data? Or maybe it can get dropped. What's the impact on that, right? And so if we decide that it's important, we can build a more resilient system. So Kinesis helps a lot with that, right? Especially when you have outages. We thought we were going to need to build circuit breakers into our Lambdas, but it turns out when you're using all these managed services, AWS doesn't need you to be like a friendly, like a good citizen when they're having an outage. The SDKs have exponential backoff built into them, and so you can see sort of when there's an outage, your Lambdas keep calling, say S3, and there's an error back from S3, and the Lambda throws an error, and then the message stays on the Kinesis stream, and that Kinesis stream backs up, and then eventually S3 comes back, and your Kinesis stream empties out, and you're back up. And you don't need, because these managed services are all, hardened and are capable of standing themselves up in the face of people continuing to make requests, we didn't need to build those circuit breakers, which is handy. You only need circuit breakers if you have to be nice to the other services. And when somebody else owns it, it's their responsibility to deal with people who aren't being as nice as they could be.
Have you experienced AWS step functions?
Yeah, so step functions is, I think, really cool. Because the thing about Lambdas is they're stateless, right? And ephemeral compute in general needs to be stateless and there's an asterisk on there, right? You can cache state in lambdas between functions and that kind of thing. But those are optimizations from a high-level perspective. Ephemeral compute is stateless, so you need your state somewhere, and often that takes the form of a database of some kind. But often you need an ephemeral state to stick around as you're managing workflows and transactions and things like that. And that's what step functions is for. It allows you to build little state machines that have various kinds of computation in it, and various kinds of conditions and loops and all these kind of things. And so that's really cool. There's a couple of problems with it. One is it's expensive. So part of what it does is, so it's built by the same people who built Simple Workflow. So it's built around business processes. So you can have these state machines open for a year, all these things. And so it's built to be durable. It's built to be auditable. And that means that when they check in state, they want to be really sure that that state is there, which makes it expensive. If you're looking for something where you can kind of play fast and loose, and again, if you drop some things on the floor, that's okay. State machines is not yet good for that. Or step functions is not yet good for that. I think it'll get there, but their initial implementation is built around this sort of other use case. It was originally relatively low volume, but it's gotten better. And the integrations, so like you can call Lambda from step functions, but only synchronously. So if I have a so I can only use Lambda to do things that take 5 minutes or less. If I want something where I have an event-driven workflow where Lambda kicks off a whole sequence of events that take 3 hours, and I want to come back around to step functions at the end, I can't do that yet. I think it'll get there for that too, and that will be really powerful because you can kick off a long-running Athena query or a batch job and manage things that way. Or have a human in the loop, right? Have your Lambda send off an email to somebody who needs to approve it. They click on it, it goes to API Gateway through that link, which goes into Lambda, which comes back to step functions. Like that'll be really powerful. But not yet. Again, it's this trend upwards, but there's still rough edges around step functions. It's still super useful. I don't think we have step functions in production, primarily because we have some other, so because we're a very early adopter in serverless and we have sort of pushed the boundaries of what was possible, we have a lot of solutions that we've matured around making things possible around what was available. And so we have solutions built around like SQS for managing transactions that would be a good use case for step functions, but we have no reason to move off of the thing that we built because it works well enough and it would just be extra time that we could apply to something else.
When you said expensive,
Yep.
Expensive in terms of money,
Yeah.
development cost, or?
Development cost is very low. Just
Okay.
money.
Money, okay.
Yep. If you want to try and, if you wanted to invoke 1,000 a minute, it's going to cost you a bunch of money.
So kind of a three-part question, but they're all related, so it'll be
Sure.
quick. So do you, you mentioned, I think you said Python's the language you typically
Yep.
use for Lambdas, right? And do you see like a continuous delivery of changes throughout the day? Do you have work on a schedule? One part, right?
Yep.
Do you use the AWS developer tool, pipeline tools, or any of those? And, if not, what
I thought
do
there
you
were
do?
3 parts.
3 parts. The last one is, if not, what do you do?
Oh yeah, okay. So the trick about our production application that supports our connected robots and apps is that rollouts to the cloud are usually coordinated with firmware and app releases because there are changes. Usually you're rolling out some sort of something all together. And so our pace is relatively low for our cloud releases. So that's, I don't know, once a week-ish. But they roll out much more frequently to our various testing environments, right? And so those are, on a daily basis or faster. The other thing is that before we roll into production, there's sort of a long, there's generally a long pipeline of robot testing that has to happen associated with the firmware updates and all those things to make sure that it all works well together. That gates like cloud updates. So there's that. The deployment of those applications. Dirty secret is on-prem Jenkins server.
Okay.
Yeah, I know, right? So yeah, it's not even running on EC2.
So Jenkins is pushing the Python code out.
Yeah, and it's deploying the code into S3 and the cloud formation to set up the resources and all of those things, and that's again because of all the things that are associated with the deployment. It's push button, but not continuous delivery.
Sure, yeah.
Our next generation of services that we're building are deployed independently. And we're looking at features that will be much easier to roll out independent of the app and the robot. Like we're starting to get to the point where we have more of those features that aren't reliant on a firmware update or an app update to work. We're looking at code pipeline, code build for that. There are a lot of restrictions on code build around being able to connect it down to your network to access your internal repos and stuff.
Is that what you're doing? So you're using Git internal repo, Git repo as well, or?
We've got, we've got like internal PyPy, right, to serve out the packages that we develop, that kind of a thing.
Yeah.
So yeah, it's like you just get into networking issues with code build. We're interested in trying it out, but we're trying to solve those problems. It'd be nice. One of the nice things about going to something like code pipeline and code build is less about getting rid of the server itself and more about being able to make those pipelines more self-service for teams. So instead of having to have central administration of those deployment things, the hope is to turn the people who currently have to administer a Jenkins server into tool builders that are enabling teams to deploy their own pipeline infrastructure.
Thank you very much.
Cool.